My name is Chris Hanton. I'm the Director of Digital Transformation at Ikon Science, and my work seeks to understand how we can harness the technological advances that are being brought into our industry to really generate business value moving forward.
Hello, my name is Andrew Geary, and welcome to Seismic Sound-Off, in-depth conversations in applied geophysics. In this episode, Chris Hanton, Director of Digital Transformation Solutions at Ikon Science, discusses the latest insights using machine learning and artificial intelligence. Chris highlights one frequently overlooked variable that can undermine the best technology. He also shares how technologists can ensure data is trustworthy and valuable, and presents a use case for investing in machine learning and AI outside of increased efficiency. Chris also spotlights machine learning's role in addressing climate change and ends with some new developments that will surprise people. This is a deep dive into the role of quality data in cutting-edge work and the best ways to harness the benefits of machine learning and artificial intelligence. And now my conversation with Chris Hanton. Well, speaking of technology there, your job does allow you to work at the forefront of technology regarding machine learning and AI, yet something less cutting edge can undermine all of the best technology. What is that?
Well, there's a few things, to be honest. The number one, which always comes back to, is obviously data. In fact, there was a presentation yesterday where Sushma Ban, who's the previous CDO at Shell, said that 80% of digitalization comes down to data utilization. But I think the other thing that we also need to focus on is culture and processes, both of which are obviously absolutely vital, but it's data that really holds us together. Without data, then we're really going to struggle as an organization.
Was culture and process two separate things there or one?
Well, they're two separate things. You need processes to really be able to leverage data. So data which isn't being applied to a business challenge is really a net cost to an organization. And in order to apply it, then we really need to have the processes. And then we need to have the culture, which enables us to be forward thinking, be able to change how we view, how we utilize data in organizations. And that's a slow burner. That's not something that's going to happen overnight. And a lot of that comes from being able to see, well, what are the benefits? What's the value that this new way of thinking is really going to drive, not just to the business, but to our users on a day-to-day basis? How can we improve what you do on a day-to-day and ultimately make your job more rewarding and more valuable?
Yeah, I imagine the culture of an organization can be such a difficult thing to maneuver around. So I can kind of understand maybe why that's not discussed too much, but why is even the quality of the data inputs rarely discussed?
I think, for want of a better term, it's not the sexy side of moving towards a digital business. Everybody's always interested in the utilizing the latest and greatest technology, whether that's a cloud, whether that's ML, whether it's AI, whether it's using edge processing, for example, to really generate business value. The other part of it, the data management, the data quality aspects of it, is the part which it costs money. It doesn't deliver immediate efficiency gains. You have to utilize that data to do something with it. But if you don't have those strong foundations, then the great technological innovations that you bring in really will fall on their face. So it's all about, we've got to have that data platform and foundation if we're really going to make the gains that we're hoping to.
So I think foundation is a great word there. How can people start ensuring that the foundation of their data is trustworthy and valuable before they input it into this technology?
A large amount of it just comes back to understanding lineage. Where did this information come from? What's happened to that information that I'm dealing with today? And really trying to unpick that side of it. It's very hard to go back over existing data. And so a lot of the work that's done within the industry is focused on forward thinking. Okay, well, when I get this data in from the field, from a drilling rig, I'm going to handle it in this way that will enable me to be able to speed up the decision-making process, be able to get it into those cutting-edge workflows quicker than we've done before. Where the real challenge comes is, how do we handle the legacy data, the data that we've been collating for the last 40, 50 years? It's in various different states of repair. It could be in paper form still. There's a lot of that still hanging around. There's PDFs. Even if you're dealing with digital data, it's, well, what's happened to it? There's so many things that could happen to it. Going back to the vendor isn't always a viable solution. It's certainly not the most cost-effective method. And so that's a big part of where those processes I was talking coming into. It's like, well, how do we handle this data? Do we handle all this data? What's our choices there? And sometimes you have to make quite stark decisions about what information we're going to utilize going forwards and how we're going to utilize that information going forwards.
What aspects of this data collecting and this data process could be automated?
So there's quite a lot. Obviously, going forwards, then the data acquisition itself, bringing that in, cleaning that up, QCing it. Pretty much every organization has some kind of ideas of the gates that data needs to go through before it can be applied. A lot of that is manual processing at the moment. A lot of that requires specialists to be able to get logs in, for example, and be able to look into those logs, perform a composite log suite, verify it, and then push it into the various interpretation teams. We have less of those specialists across the industry than we used to have. And often we're asking them to do more than they've ever done before. And so if we can automate some of those workflows, or we can automate some of those mechanical repeatable steps, then that's absolutely something which is huge. The other part of it, and this is very much for mature basins, is, well, can we do some of this anomaly detection? Can we automate some of that? And I really think for the industry, that's where ML/AI can really help, in terms of dealing with huge amounts of data, getting in a new well, for example, and then looking at the values and being able to see from more of a geological, geoscientific standpoint, do these values, do they agree with the other wells which I have within this area? Are they anomalies? And then you can start looking at, well, what's causing that anomaly? Is that something to do with the underlying geology? Or is that something which is more to do with how that data is being handled, how it's being processed? Are there errors that have been induced during that workflow? And so I think screening is a huge amount of where we have an opportunity to automate a lot of those data quality workflows.
Yeah, when I think of automation, I obviously think of technology and machines and software, but there's obviously people that are at the foundation of that process to start with. What are skills and knowledge necessary to automate these processes for a business?
I think a big part of it is tying into what do we need for the business. We've got to remember we're not in academia. We have budgets, we have timescales that we have to be able to hit. So the first thing is maintaining that business viability. What do we need to be successful moving forwards? And so that's the first part of it. I think a lot of the other parts of it are the subject matter expertise cannot be overlooked. And no matter how much we bring in technology, we're always going to have the fact that we are dealing with very specific types of information. We're dealing with very specific geotechnical challenges. So we need to maintain that we have those folks who can speak both languages. Can you speak the subject matter expertise? Can you speak the digital technology language? You don't have to be experts in both. But if we have that bridging capability, then obviously we have the ability to make sure that the technology is deriving that business value moving forwards.
You know, the business is having these conversations about, looking at machine learning and AI. You've talked a lot about legacy data. Is there a big difference for a company that maybe traffics mostly in legacy data versus gathering new data about what processes they would want to develop and utilize in their business?
Yeah, and you get a lot of companies that are in both spaces, obviously, as well. And solving it going forwards is certainly easier, particularly the way the industry is moving forwards in terms of trying to increase the openness. And obviously, we see initiatives such as the OSDU, which is really focused on trying to build out standards. Now, if we can maintain that the industry develops these standards and then abides to it moving forwards, then that means we can have repeatable workflows. And that means that we can spend less time in what OSDU terms the non-competitive space and really focus on gaining that competitive advantage, which is applying our subject matter expertise to various insights. The problem with legacy data is that it's already been acquired. It's already been stored in whatever methodology it was used. And it's not always done in the most effective manner. And so a lot of it comes down to understanding, well, how can we harmonize this data? How can I bring maybe the same data type from 3 different vendors who have called those various curves, for example, 3 different things? They use different QC workflows to get it into there. How can we look to harmonize that? And what can we do? And I think there will always be a certain amount of of vagueness in the quality of legacy data, particularly when we start going back through the decades. And that's just an inherent uncertainty, which is going to have to be communicated to the eventual consumers of that data. And it just becomes another part of the workflow. Obviously, the latest and greatest data that's being put through those contemporary QC workflows should be of higher accuracy and should have a higher value than maybe some of the legacy information. But ultimately, we need to be able to try and bring them all together into a central environment.
That makes a lot of sense there. Could you share an example where utilizing quality data proved significant?
Yeah, absolutely. I mean, there's numerous ones, and I'm sure folks listening to this have probably experienced a few themselves. One which I often go back to, and it's quite niche, but it was regarding depth shifting. And so we had a client organization a few years ago now who were dealing with thinly bedded laminated sands and shales. And obviously, when it comes to that level, making sure that we have perforations, which are targeting the sands, not the shales, is absolutely key to making sure that we get the optimum recovery from that well, that the production profiles are exactly what we expect them to be, and that ultimately we maximize the revenue from the drilling engagement there. They had spent a large amount of money on acquiring core data, but it was underutilized, largely due to the fact that core data is incredibly hard to manage. And so utilizing some of our technology out there, some of the multi-scale visualizations and being able to harnessing different scales of resolutions of information, they were able to really refine those depth matches, make sure that the depth matching was optimum, so that when they ran the perforations, they were able to really focus on perforating the sands, not the shales. And then being able to run that at scale, so being able to run that across the entire reservoir that they're working on. And obviously that made huge changes to the optimization of those completions. And once you start speaking about completions, once you start speaking about the drilling side of it, that's really when you start getting management looking into it, because those are the things that are really, really cost intensive. And so if you can make fundamental gains in those sides, then it obviously helps in terms of the value proposition conversation.
So let's kind of have a given here that the data is high quality. What can cutting edge analytics and machine learning produce from the data that the best geophysical minds would not?
I think a large amount of it comes down to scale and speed of application. We have got experts within our domain who have been working in this industry for 25, 30 more years. They have considerable insights, but what they don't have is an unlimited amount of time and an unlimited amount of resources to be able to apply this at a time. And so you see a lot of the work is done on really increasing the scale. And I saw a very impressive demonstration from a vendor fairly recently at the Energy and Data conference in Austin, where they were able to pick an entire field worth of faults within a couple of hours running on AI ML. That same workflow would have taken weeks and months of a specialist to be able to pick all of those. The other thing which I really think it assists with is removing some of that bias of thought, because we generally work the same assets, we work the same areas, we become used to certain characterizations, and that can really help us. That can help us understand the underlying geology and the mechanics of exactly how this reservoir is held together. But if we move to a new area, we can sometimes bring those learnings across, and sometimes that's maybe not as beneficial as it could be, and it often helps to have a kind of a more of an open opinion. And so I think the other thing which it can help with is maybe removing some of that bias of thought, which we often develop, and helping us to gain new insights where maybe we wouldn't have seen those in the past.
You published an article in Oil and Gas Engineering back in September of 2021. And since that article was published, the stock price of many oil and gas companies have increased dramatically. What is the use case for investing in machine learning and AI outside of increased efficiency?
I mean, efficiency is always going to be a big part of it, but efficiency is much more than just reducing lost time. It's speed and nimbleness to adapt. As we see, the oil price has changed dramatically over the past 24, 18 months. And it's moving in much quicker cycles than we've seen in the past. And so we need to be able to have nimble organizations who can adapt to that price change as much as possible. And obviously, if we can apply machine learning to that in order to speed up the processing and the delivery of wells. And that's going to be key in making sure that we can, essentially, when the price is right, we can be poised with those rigs ready to go, obviously notwithstanding the logistical restrictions which are there. The other part of it also is revisiting some of those previous wells that we've drilled, making sure that we've maximized the work that we've done, maximized our insights, and maximized the profitability that we've gained. It's not just about efficiencies, it's about what can we do that we haven't done before, perhaps. What can we generate out of both new fields, but also existing fields to really maximize the profitability of our parent organizations.
What role might machine learning and analytics have in addressing climate change?
That's a good question. And I think you can look at it in two ways in our industry. There's what can it do for our existing hydrocarbon extraction? And a lot of that comes down to improved accuracy. Obviously, if we can have better insights of the subsurface, we can drill wells more effectively, more efficiently, hopefully reduce the amount of lost time during drilling operations. We can also ensure that the wells are positioned in a strategically more beneficial area, hopefully reduce the number of wells you have to drill. All of that obviously minimizes and reduces our carbon footprint. So in terms of many of the organizations within our space have got quite aggressive net zero targets. So if we can ultimately reduce the carbon footprint in the drilling and extraction, then that's going to be a huge part of meeting those. The other part of it is with the energy transition and carbon management as well. A lot of the sequestration projects which we're looking at are utilizing existing reservoirs which are either in or surrounding hydrocarbon activities. And so if we can utilize ML AI to assist with that screening, assist with that understanding of, well, which of these prospects that we've been working for many years can be pivoted towards this new sequestration workflow, then that's obviously going to help us in terms of reducing the carbon footprint across humanity. If we can really start delivering on those sequestration goals, which are a key part of the climate pledges moving forward.
What will be a couple of new developments with machine learning, AI, and analytics that will surprise people?
I think one of the things, and I saw, again, another very good presentation of this Energy and Data recently, which was the harmonizing of the human and the machine aspect. A lot of the work that's been done at the moment, and particularly when this comes to a lot of the work done in seismic, has been about, we'll set it up, we'll set up this model, we'll run the model, and then we'll look at it, and then we'll retrain the outputs, and we'll retrain the inputs and make sure that ultimately when we run it again, it'll be more effective. That's not the most effective way of working. It's quite a linear way of working. And so some of the advancements I've seen recently, and Blueware do a great presentation on this, is about utilizing the ability to be able to iteratively work together. And so using some of the advances in terms of the underlying file structure and the cloud computing, essentially enabling you to be able to tweak the model and update the model as it's being run. And so you don't have to go through that multi-hour process to then go and change the parameters. You can constantly tweak it and guide it and utilize that subject matter expertise, which we have within our industry, to really be able to promote more efficient gains going forwards. And so I think that's going to be a big key point moving forwards, is really looking to blend together subject matter expertise with the underlying technology in a way that maybe we haven't seen before.
And lastly here, what principle teaching or point of view has helped you succeed in your field?
I think a lot of it actually is the soft skills. Digital transformation is really like any project. It's just a very complex project deployment. And so for me, a lot of what makes me successful in my space is being able to listen to the various different aspects and being able to work with our clients to be able to bring those together. And so typically in one of these projects, we'll be speaking to the business leaders within an organization. They will have quite broad business goals that they want to meet. We'll be speaking with the end users who are facing the daily technical pain. They'll be able to tell you what would make their job better, more effective. They'll also be able to tell you where the pain points are. And then we'll also be speaking with the IT side, who will be working on their own initiatives that will align with what's coming from the management level. but they'll also be having their own various thoughts in terms of some of the work in terms of the hosting and the underlying technology stack. And so a big part of my day-to-day work is making sure that we get all those folks speaking the same language together. And so that kind of needs that translator role almost to be able to bring that together so that ultimately we provide something which is going to have holistic benefits across the whole organization. And that's when you really can start making those step changes towards being a digital company, is when we can really get all those various parts and stakeholders working together.
That harkens back a little bit to the culture talk at the top of the interview here. I appreciate your time today, Chris, and for offering some insights into machine learning and AI from kind of the data side with your role at Ikon Science, and just appreciate sharing some more information about it.
Thanks very much. Great to meet you, Andrew.
SEG produces Seismic Sound Off to benefit its members, the scientific community, and inform the public on the value of geophysics. To show your support for this show, please leave a 5-star review on Apple Podcasts and Spotify. Simply go to Seismic Sound Off on Apple Podcasts and Spotify on your phone. It takes less than 5 seconds to leave a 5-star rating and is the #1 action you can take to show your appreciation for this free resource. And follow the podcast while you are on the app to be notified when each new episode releases. Original music created by Zach Bridges. This episode was hosted, edited, and produced by me, Andrew Geary at 51 Features. The SEG podcast team is Jennifer Cobb, Kathy Gamble, and Allie McGinnis. Thank you for listening. This is Seismic Sound Off, signaling off.